Hello PLP Geometry. Welcome to the 11th video in our Unit 1. We're almost to the end. Okay, today is a biggie though. Alright, so let's go get ready to hit these proofs hard. So again, we're in Unit 1. We're doing Intro to Geometry. And again, today we're talking about video number 11. And what we're going to do here is we're going to talk about Intro to Proof. So we're going to introduce you to what a proof is in geometry. And to do that today, we're going to use our old friend, Mr. Algebra. Intro to Proof with Algebra. So in geometry, right, there are ideas that we like to prove true. And we use what are called proofs to do that. Now there are a couple different types of proofs. We are going to hang our hats this school year on two-column proofs because that's the most common type that you'll see. Okay, so we're going to talk about what a two-column proof is and then do one as an example. Your assignment for number 11 is paper and pencil. So again, be aware of that. So yeah. All right, so two-column proof. So what is a two-column proof? Well, a two-column proof is a convincing argument. Convincing argument in which statements and reasons are aligned in columns. Are aligned in columns. I'm going to highlight the word statements and reasons because those are what your two columns are titled. So when I show you what a proof looks like, you will see that statements and reasons will go in the two-column proof headings. I'm going to go to the next slide to kind of give us a good breakdown of what a two-column proof looks like. So when you are about to start a two-column proof, right, you will be given some information. So we actually will see the word given, and there will be some information, right? Typically, it's some sort of a math statement, okay? All right. You will also be given a figure. So I'm just going to put a little space over here, a figure. It's very important that you draw this figure and you mark it up. We've talked about all kinds of vocabulary so far. We've talked about congruence. We've talked about perpendicular, right? In the next video, or we talked about parallel lines, right? All of those things could be used in a two-column proof. So make sure you mark up your figure. Now today with algebra, we won't have anything to mark up, but we will next video. And then there is something you want to prove. And again, it's going to be some sort of a math statement. And again, I'm going to put two, so I can, two little squiggles. So again, this is our end result, right? This should be the last step in your proof, right? Because when you prove what you want to prove, you're done. Okay. All right, so that is the setup, right? So here's what you're going to do, right? You are going to make your two columns. So we're going to create a table. Okay. The one heading, like I said, is going to be called statements. The other heading is going to be called reasons, just like it says in the definition. Okay, and now what we're going to do is we're going to number our statements. So we're going to put statement number 1. Okay, I always like to put 1 in a circle. This is always what you were given. So notice that I was one little squiggle up there. That's matching that up there. So whatever is in the given goes right in step 1. The reason for step 1 is always the word given. I won't all caps it. That's not a big deal. Just the word given. Okay. All right. Now, the next steps are for you to decide. So we never know how many steps a proof takes. right? Again, as you look ahead, you might kind of think about how many it takes, but it could take 3 steps, it could take 5 steps, 6 steps, right? So I'm going to do 1, I'm going to do 2, do 3, and I'm going to put dot, 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 okay? In these statements here, we are looking for some math statements. So these math statements are going to use math symbols. So maybe 2 angles are congruent. Maybe 2 angles add up to 180. Maybe 2 segments are equal. Their lengths are equal. Things like that, right? And over here in the reasons for 2, 3, and dot, 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 these are going to be your justifications. How are you going to justify what you are saying? And a lot of times this involves words. So it could be like vertical angles are congruent. It could be like, substitution, right? Words that we're going to talk about in geometry. And then when the proof is done, you are at your last step. So again, you don't put the word last, but you put the last number. So whatever number you're on. This is where what you want to prove goes. So notice I put 2 of these squiggles to match what I was trying to prove. And then the last reason is going to be some sort of a justification. So it's not the word prove. You don't put the word prove. That's wrong. You have to prove it using whatever the last math justification is. And that's what these proofs are going to look like. So to warm you up towards the geometric proofs, we're going to look at some algebraic proofs. And I'll do an example for you on the next slide. Okay, so let's say that we are given, so if you want to put this as our example, let's say that we are given this equation. So 6 parentheses 14 plus x equals 108. And again, we are not going to be given a figure because this is not a geometric proof, so no figure. We want to prove, and in an algebraic proof like this, the prove statement is the answer. We want to prove that x equals 4. So I'm telling you that x equals 4. You just need to come up with that answer. Okay, so that's what you're going to be given. All right? So then what you would do is you would create your 2 columns. Statements. And reasons. Okay? And now, in the first statement, you're going to put the original equation. So we have 6 parentheses 14 plus x, close parentheses, equals 108. And in that first reason, we always put the word given. Okay. So now, in this problem, in the algebraic proof, we're just going to solve this, right? So I'm going to make each step a new color, just to kind of help you guys. So for step 2, or for statement 2, when you see parentheses, typically we distribute. So we're going to distribute this 6 to both parts. So 6 times 14 is 84. 6 times positive x is positive 6x. And the 108 comes down. This is called distribution. Now, all of these have the word property with them, so I'm going to call this the distributive property. But if you put distribution, I would not care. I am pretty lax when it comes to writing down the reasons. Okay, just as long as I know you know the gist. Okay, now, when it comes to these proofs, we typically don't show our work, but I will small underneath the equation. So next step, right, I want to get x by itself. We need to move this 84 to the left. So it's a positive 84, so we're going to subtract 84 on both sides. So I'm doing it really small. So my third step is going to be the resulting equation. So the 84's cancel, so the 6x is over here. 108 minus 84 is 24. What I used here is I did the subtraction property, and I'm going to put of equality because we did it on both sides. Again, if you just put the word subtraction, I'm okay. But this is technically the subtraction property of equality. And now the next step you would need to do is you would need to divide both sides by 6 because that is 6 times x. So we're going to divide by 6, divide by 6. So the fourth step is going to give you the proof. X equals, and 24 divided by 6 is 4. And we got what we wanted to prove. Again, the fourth reason is not going to be the word prove. The fourth reason is what you did to get from step 3 to step 4. And we did the division property of equality. Again, you can write the word out division if you want to. I'll just put div for division property of equality. Same thing up here for distributive property. I could have maybe put dist, maybe distributive. It's okay. As long as I know what you mean, we're all good. So here is an example of the type of proof process we're going to do. So I'm going to give you a small paper assignment involving some equations to do this with, and then next video we'll get into how we do this using geometry. Okay? All right, so thanks for watching this video, and we'll see you in class.